So virtual reality is, I would argue, is a special case of augmented reality. Virtual reality is where all your senses are completely occluded, they are completely covered, and you are transported into a new world, in a full 3D world. Examples of virtual reality devices and systems are Oculus Rift, HTC Vive, the Windows mixed reality devices, the Samsung Gear VR and Android Cardboard. All of these, they're at different price points, and they have different capabilities, but they're all VR devices. AR is augmented reality, where it takes your reality and it adds digital objects to it. So if I give you the elevator pitch for HoloLens, and HoloLens shows you holograms in the real world. Holograms are just like regular objects. They have object permanence, which is if you keep this cup here, then it stays there. If I come back later, it's still there. If I move around, it's still there. I can interact with this cup. The only difference is this is made of matter and a hologram is made of light and sound. So when I started studying at University of Maryland and did electrical engineering there, and after that I went to University of Illinois at Urbana-Champaign and I studied computer engineering there, and then I started working at Microsoft, and my first 4 or 5 years at Microsoft were with the Windows Phone team, about 5.5 years I think. And after that I moved and was one of the early members of the HoloLens team, which at that point in time we didn't know what we were building. We knew we had a broad vision of what we wanted to do, and it eventually became the HoloLens product. And that journey was about 5 years as well. And about a few months ago I left Microsoft and I came and joined Pocket Aces. I was responsible for all the low-level camera input and processing of the camera data. So HoloLens has 7 cameras on it, and all of them goes to a custom chip that we developed and built, and we process all the data on there. So I wrote the operating systems for that chip. I worked on the camera input pipelines, and over the last few months I ended up supporting the manufacturing of HoloLens. So I ended up going to China a bunch of times to help with setting up the assembly line, figuring out what kind of errors they are facing so that we can either fix it in software or tell the hardware and the design and the mechanical team saying, this is where the errors are happening and you need to find a solution, because it's not a software problem, but we can detect it in software. If you want to get into the kind of stuff and the kinds of places I'm talking about, the Microsofts, the Googles, the Facebooks, all of these guys do AR, VR, all kinds of stuff, right? Uber, like name any of the top 10, 15 firms in the industry. They don't actually care about any specific technology that you know. Like, oh, I know JavaScript, I know Java, I know Angular, I know whatever. Nobody cares. Are your fundamentals right? Right. So if you're a computer engineer, pick a field that you like within the larger software, hardware, computer engineering space. Let's say I chose embedded systems. Then get your basics right. Understand how communications work. Understand how programming works. Understand why something happens. So a simple example is in embedded systems, I need to know C and C++ very well. But it's not the fact that I need to know the language very well. I need to know what's happening. So do you understand how does C++ implement classes? Answer that question. How does C++ implement polymorphism? Understand that, be able to say, oh, this is how memory works, this is how the pointers work, blah, 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 blah. That demonstrates a level of comfort with the technology. If I want to make it more general, find the layer in which you want to work and make sure you very, very, very well understand the layers above and below you. And you need to be a master at your own layer and be not quite a master, but a very good student of the layers above and below you. Tomorrow Python, tomorrow there'll be a Python VR library, there'll be something else. There is OpenVR right now. Microsoft has its own API. Apple's getting into it. Google's already in it. All of these things are just more or less identical API sets, more or less. But the fundamentals have to be basic, strong. So AR/VR, you need to understand 3D math very well, right? 3D vectors very well, graphics, 3D graphics well, so that you can place things in space well and interact with them and have them do things in the 3D world. That's where, understand how to write code for that, and then the technologies can come and go and you'll be fine. And nobody creates anything worthwhile sitting by themselves in a dark room. You have to run a team. There's a phone screen. If you succeed in that, you get a call and say, hey, we want you to fly over to wherever this company is. If it's Facebook, you'll go to California. If it's Google, you go to California. If it's Microsoft, you go to Seattle. You fly over, and then on the day of the interview, you speak with HR for half an hour, where the HR person will lay out the day for you. And then at Microsoft, you will have 5 interviews after that. 2 in the morning, a lunch, and 2 in the afternoon. All of these are technical interviews. The lunch is slightly more focused on soft skills, and that is more free form. The interviewer can choose how they want to do it. But all the other interviews, you are in a conference room or a meeting room or a interview room with a whiteboard and a marker, and you're asked to solve problems, write code on the whiteboard, right? Straight up. And then at the end, if you do well, all the interviewers come together, give feedback, and then if it's all positive, then you're in. All it takes is one strong no to not get hired, because all of these companies are focused on making sure that there are no false positives. False negatives are okay. There is enough supply. You don't want to make a mistake in hiring. Missing out on a few is okay. So now let's talk about the content. None of these companies expect a new college grad to actually know any specific technology in detail, but they want to know how you think and what your attitude is towards problem solving. So one of the most popular questions is reverse a string, and then they will say, oh, what language should I use? Use whatever language you are comfortable with, but reverse a string, or flip all the words in a sentence. If you say, my name is Viral, make it look like Viral is name my.
Write a code for that.
Write code, literally write code. It has to be legal, legit, clean code on the whiteboard. You don't have a compiler, you don't have a keyboard, and explain how you get to it. So what I like to call it is interviewing for software is a performance art. You have to act, you have to communicate, you have to show your work, because the interviewer is not interested in whether you know the answer or not. If in fact you know the answer, tell them. They will value it so much more. But this will be 5-6 interviews like this, all algorithm based. Google focuses more on scalable algorithms. Facebook and Google will, large data sets. Microsoft is very diverse in that sense, so every group will ask their set of questions and where they are working. I am not aware of how the other companies do interviews, but they are similar. They're all asking for fundamental algorithmic questions. So a straight up tip for you, look up Cracking the Coding Interview. That's a great book. Programming Pearls, that's a great book. And Programming Interview with Exposed. These 3 books make sure you fundamentally understand how the whole thing works and the whole books work. These 3 books and you'll be fine. VR is not going anywhere. VR is not going to go away in 5 years. AR is not going to go away in 5 years. What changes in every few years is programming techniques and programming methodology. Like you went 5 years ago, you were using jQuery, now you're using Angular, tomorrow you use React, day after tomorrow you use some other fancy new term. But these are just different tools. VR lets you interact with the world in full 3D. Okay. So let's assume not the current state of VR, but let's fast forward 5-7 years, where you'll have a completely independent VR headset with all the compute in the head. It's going to happen, right? The resolutions of the screen right now are really bad. They'll get better. So now you have a full-fledged computer on your head, and you are completely untethered. You can walk around and all of that. Now you can totally imagine. In this particular, in the VR case, AR has a lot more applications than VR, because VR takes you out of your environment. So you can't really walk too much without hitting a wall, right? You have to know where the wall is and all of that. It's painful. It's a whole different problem that needs to be solved. But in VR, you can imagine, you can have a 3D model of a beating heart in front of you. Nobody has seen a 3D model of a beating heart in 3D so far in life ever. The moment you open a heart, it stops beating. So you see the heart, a medical student, or you see a 3D model on a screen and you have to rotate it around. So you've seen a 2D projection of a 3D heart. You've never seen a 3D heart working, and then you can put a slice through it, open it up, and it's still beating. Nobody's ever seen it. This can fundamentally change medical students' understanding of how heart works, or any other part. My favorite part of working on the team, once we had it working, was to see a person use it for the first time. There's a year-to-year smile, because they cannot imagine, like, this is real. And all they're seeing is a cube in front of them. Nothing fancy yet. They will see it, like, as the demo progresses, they see more and more complex things. But it is my favorite thing ever to watch somebody use the HoloLens the first time. Nobody likes to see the sausage made. No, I mean, there is a lot of sweat, there's a lot of glamour. Well, the glamour happens once you have a finished product. When you work on a product like this, where you say, I have a vision, I want to do something like this. How do we do it? I don't know. Do we have enough technology in the world to put a computer on your head and not burn your forehead? We don't know. Let's figure this out. So at every step, in any problem in HoloLens, there is no simple answer. It's a puzzle with lots of moving pieces. And if you look at any other project, there might be one piece that's new, and everything else, people understand. It'll take work. We'll get there. Here, there are fundamental problems that we are trying to solve in each one of these pieces. Give them good projects, take out the exams, right? Reduce the amount of exams. Programming class exams don't make any sense. Convert it to a project-based thing. Everybody has to work on a project, and then put systems to prevent plagiarism and copying and all of that kind of stuff, which they all exist. And these are not completely solved problems, but there are tools available for this. And make them better programmers, better technologists who understand how to do stuff. The fact that companies like Infosys, Wipro take freshers, and then they have an academy for 6 to 8 months. Isn't that telling that colleges are not teaching anything? A lot of them learn because they want to learn. It's self-motivated. They form groups and they're interested in technology and they learn. Every time you code, you get better. Every time you do something, you get better at that thing. I mean, it's not a surprise, right? So now just do more of it. I wish colleges would provide a structured, supportive environment where they can do this and learn, versus searching on Google and how to do things, because there you might get the answer for your problem, but you never understood why it was a problem in the first place.